So in the last class, we were discussing about the important topics, the same as we will discuss it today. And today, the topic we're going to discuss is redox and some topics of structure of atom, that is quantum number calculation, as well as we will go for the environmental based questions also. Okay, we'll try to just sum up all these things and with whatever the main important topics we will discuss in this video. Okay, and first discuss what is redox. So as the name suggests, red represents the reduction and ox represent the oxidation. So the reaction in which the oxidation and the reduction occur simultaneously, that reaction is known as reduction. Also, that reaction is called as reduction oxidation, that is redox. Okay, so in this reduction reaction, one of the reactant or one of the thing is getting oxidized, right, while other one getting the reduced. So for example, I'm writing Cu plus Zn gives out Zn2 plus. Cu plus Zn2 plus gives out Zn2 plus Zn. So here zinc is getting reduced while copper is getting oxidized. So this type of reaction is called redox reaction. Inside the redox reaction, one important topic is that is disproportionation reaction. Disproportionation reaction. And if I talk about this particular reaction, disproportionation reaction represents like the reaction in which same element in the given form undergo both oxidation as well as reduction. The same reactant is going oxidation as well as the reduction. So this type of reaction is called disproportionation reaction. For example, we have Cl2 when react with the OH negative, it gives out ClO3 negative plus Cl negative plus H2O. So for the balancing, this is 3, 6, 5, and here 3. So this is the reaction. So oxidation state of Cl here is 0. Here Cl is plus 5. Here Cl is minus 1. So you can see from 0 to plus 5, oxidation state is increasing. So it means we are undergoing the oxidation reaction. While Cl is going from 0 to minus 1, that is we are going under reduction. So it means the Cl is going oxidation as well as a reduction. That's why we are saying this reaction as disproportionation reaction. Okay, so both the things if occurring in the same element, that's then only we say disproportionation reaction. Okay, one more important, that is comproportionation reaction. Comproportionation reaction. This comproportionation reaction means like two species with same element and two other different oxidation state form a single product. Forms a single product in which the element is in an intermediate oxidation state. Okay, you can say simply reverse of the disproportionation reaction. So simply we can say like Ag2 positive plus Ag. It's in the aqueous form, it's in the solid form. When it's going to reaction, it gives out Ag, 2Ag positive ion. Okay, in the aqueous form. So in this reaction, you can see Ag solid is converting into Ag. Okay, this is oxidation. And this Ag is again converting into Ag positive. This is under reduction. So both the things are occurring in the same element. That's why this reaction is called comproportionation reaction. Okay. One more important topic of this particular chapter, that is oxidation number. So how to calculate the oxidation numbers? For example, like I'm having example KMnO4. See Mn, you have to find the oxidation number of Mn. So the value of so if there is no charge, then it you'll put equals to 0. Okay. For example, potassium is 1. Okay, and Mn just you have to calculate for Mn, so you have to just take it as X. Oxygen having the -2 charge and 4 oxygen is there, the -2 into 4. So X will be equals to 8 minus 1, that is equals to 7. So here the oxidation state of Mn is 7. Okay, what else sometimes it happens like when we are having charges, MnO4 negative. So Mn is X, you have to calculate the Mn. Oxygen is -2 into 4, and whatever the charges, you have to put it equal to the -1. So it will be X is equals to -1 plus A, that is equals to again plus 7. So this is the way you have to calculate the oxidation number. Just you have to remember, if the oxygen is present with any of the high electronegative element, it means what exactly happened, like it means we are having the -1 charge, or you can say oxygen can be in the positive form here. Okay, so this is quite important. Next thing, let's see, that is more example we'll do simultaneously. And most important topic is of this chapter is that you will get the question from the balancing point of view. So balancing is in two form. Okay, we'll see how balancing is there, but let's discuss more example of this oxidation state, like CaO2. Calculate X as calcium, oxygen -2 into 2, that is equals to 0. X is equals to +4. But sorry, wait. You have to okay, you have calculated the value of okay. No, wait, there is something wrong. Wait, you have to calculate the oxidation state of oxygen here. Now it will be more good. Like calcium is 2 plus oxygen is X, and into 2, then it will be 2X is equals to 0. Then 2X is equals to -2, X is equals to -1. So see here the oxygen is in -1 form. Next we can take more example like NaHSO4. You have to calculate the value of S. So Na, just take 1. Okay, hydrogen is again 1. Sulfur you have to calculate, so it will be like X plus oxygen is -2 into 4 minus A, that is equals to 0, just because no charge is there. So if when you calculate it, it will be 8 minus 2, that is equals to 6. Okay, so you have to calculate the value of different elements. For example, let's take off the potash alum, K2SO. Potash alum, no, just it will be quite big. So just we can have more example like H2S2O7, oleum. Okay, so you have to calculate the value of sulfur. So it will be 2 plus 2x plus oxygen -2 into 7, that is equals to 0. So it will be 2x minus 12 is equals to 0. X is equals to 12 upon 2, that is equals to 6. Oxygen is 6, or sulfur is 6 here. So you have to calculate this value of this X according to the particular question. Whatever is underlined element, you have to calculate, and sometimes underline is not given, then you have to do it by your own way. Next, let's do some examples of balancing. For example, so we have two method balancing. One is ion electron method, in which you have to divide the equation in two half, reduction half cell or oxidation half cell. Second way is oxidation number method. So we have like this. So first let's go for the ion electron method. In ion electron method, what we have to do, we have to divide the equation in two parts. For example, I'm having one equation, MnO4 negative plus I negative gives out MnO2 plus I. Okay, I2, sorry. This is the reaction you have to balance in basic medium. Okay, basic medium, you have to balance this equation. So first you have to just divide the equation in two half cells. So first I'm dividing reduction half cell and oxidation half cell. In reduction half cell, like for example, MnO4 negative is converting into MnO2. How you'll get the which is oxidized, which is getting reduced? You have to calculate the oxidation number, and then after calculating the oxidation number, what you have to do? You have to just see if the oxidation number is decreasing, it means there is a reduction. If oxidation number is increasing, then it means there is oxidation. Now second is I negative is converting into I2. So I'm dividing it into two parts. So you have to balance the charge, you have to balance the equation. Okay. So first we'll balance in this particular reaction, we'll see oxygen balancing. So MnO4 negative is converting into MnO2. So on the right hand side we have two oxygen, on the left hand side we have four oxygen. Okay, so where the oxygen is less, just add water. Okay, so it's still not balanced, so you'll write 2. So now the oxygen is balanced. But what about hydrogen? We don't have hydrogen. So if I write here H2O also on the left hand side, so it will be again the hydrogen is not balanced, so it will write 2. Now the oxygen is increased, so in that particular case just add OH negative. So I have added 4 OH negative here and I will add 4 H2O. So this reaction is now balanced. Oxygen is now balanced. Okay. Wait, let me check now whether it is balanced or not. MnO4 negative. Go to. Okay. No. So here 2H2O on the right side is there and 4H2O. So just to balance the equation, you can do one thing. Just remove this 2H2O from the right hand side. And here just add 2H2O. Now it will be balanced. 2 to 4, 4 OH that side. So this is a balance. Now oxygen and hydrogen both are balanced in the left hand side. Let's see the right side. Also just balance the charge here. MnO4 negative plus 2H2O plus 3 electron gives out MnO2 plus 4 OH negative. Now the charge is also balanced. On the right hand side, if you'll see, 2I negative will convert into iodine. For balancing the charge, it will be 2I negative gives out I2 plus 2 electrons. So both sides 2 negative electrons are there. So charge is also balanced. Now for our overall reaction, what you will do, just write both the reaction together. It will be MnO4 negative plus 2H2O plus 3 electron gives out MnO2 plus 4 OH negative. And second equation was 2I negative gives out I2 plus 2 electron. So on above and both sides, you see the electrons are not balanced. So just multiply the above equation by 2 and remaining equation by 3. So it will be 2 MnO4 negative plus 4 H2O plus 6 electron gives out 2 MnO2 plus 8 OH negative. While left on the second equation, that will be 6I negative is converting into 3I2 plus 6 electron. Now the electrons are balanced. You can cancel out the electrons and just write the damn equation. That will be 2 MnO4 negative plus 4 H2O plus 6I negative gives out 2 MnO2 plus 3I2 plus 8 OH negative. So now this will be considered as the balanced equation from the ion electron method. So probably this is very easy for doing, but sometimes you just need to calculate the oxidation number first. That then it will be very easy for every person to do it. Okay. In acidic medium, let's see one example. In acidic medium, like example is given like Cr2O72 negative plus SO2 gives out Cr3 positive plus SO4 2 negative. So this is the equation. You have to balance this particular equation in the acidic medium. So for the calculating it in the acidic medium, what you have to do, just divide the equation in two parts. First, you have to calculate the oxidation numbers. So in the Cr2O7, it will be 2x plus minus 7 into 2, that is equals to minus 2 plus 2, sorry. 7 to the 14. 12, 6. Yeah, it will be plus 6, and it will be here plus 3. Sulfur here, x plus minus 2 into 2, that is equal to 0, x is equal to plus 4. Here plus 4, the right hand side x plus minus 8 is equal to minus 2, here 6. So Cr is getting reduced while the sulfur is getting oxidized. Divide the two equation. Like Cr2O72 negative is converting into Cr3 positive, while SO2 is converting into SO4 2 negative. Okay, this is the equation. So for the balancing the equation, what you can do, first either just balance it and just balance oxygen and hydrogen later on. Two things are there. Okay, first method the way I taught you earlier. Second is this way. Like see, on the left hand side we have 2Cr, so this right hand side will be 2Cr3 positive. 6 is converting into 3. So how many electrons? It means we are like 3 electrons uh, is just reduced. Okay, so it 3 electrons are reduced. No? 3 electrons is added. So that's why the charge is less. So it will be 3 electron, but 1 Cr na 1 Cr is converting to Cr3 positive. So 3. And if 2 Cr is present, it means 6 electrons. So here we have 6 electrons. Here SO4 4 to 6 it's converting. If it is converting from 4 to 6, it means 2 electrons are added. 2 electrons are added. So it will be 2 electrons. So for balancing it, you multiply the above equation by 1 and below equation by 3. Okay, multiply this equation by 1, multiply this equation by 3. Okay, or you can do one thing instead of this. If you're getting confused, we can do one thing. Wait, just don't write 2 electrons. So just write 3 electrons here. Okay, and just don't write 2 here. Now it will be more easy, like multiply this equation by 3 and multiply this equation by 2. So everything will be balanced. So it will be Cr2O7 plus 6 electron. Why I'm not multiplying Cr? Just because already the 2 Cr is present. So it will be 2 Cr, 3 positive. Here it will be 3 SO2 plus 6 electron. Sorry, minus 6 electron. Guess out 3 SO4, 2 negative. So left side on the right hand side, you can see. Yeah. So two equations we got. Just combine both equation. It will be Cr2O7 plus so 2 negative 6 electron gives out 2 Cr3 positive. Here it is 3 SO2 minus 6 electron gives out 3 SO4 2 negative electrons. Electron just cancel out. It will be Cr2O7 2 negative plus 3 SO2 gives out Cr3 positive plus 3 SO4 2 negative. Now for balancing the oxygen and hydrogen, just calculate the oxygen number on the left hand side and right hand side. On the left hand side, we have 7 here and 3 to 6 here. Oxygen and hydrogen 12 here. So 6 plus 6, 6 plus 13, and right side 12. Just add 1 on the right hand side and here the left side 12. This is also correct method. As the example, just because sometimes they will get more of the questions from this basic code only. Just because an election method is quite important. Just leave this particular method and more just and then uh, uh, what why the is it negative and are negative. 3 positive plus this came with it's, uh, this goes for that is this but it is they die. Yeah, and a lot on in A or Y what A is for the A amount of I of example M uh, one that is boils also mind and ideal are also important for boils stars and gas uh, yes, is temperature what in one yeah the or at constant temperature water is equal to the pressure volume increasing the pressure will decrease like imagine initially this V1 is one V1 the P is V A that is divided by one volume V specific was equal to the V2 is K1 upon K. This is this value of K is equal to V and K is equal to V. Left hand side is same, so we can say like V1 is equal to V2 V2. Volume if they are involved, volume is like temperature at constant pressure. Fixed volume V1 temperature V1. So V1 is like proportional to V1. V1 is equal to K upon K. K is equal to V1. The gap V is like because volume become V temperature become V2. V2 is like V2 is equal to K. K is equal to V2 upon D. Is equal to 1. But because from equal to 1 and V1 upon V1 is equal to V2 upon this. If they are it like gas. So that remember what it was, what it was. Okay. So about right, oil also the temperature falling so right V sorry V exactly put initially V1 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 and V1 is equal to V1 upon K is equal to V1 V1 finally V2 temperature V2 is like V2 is equal to K and K is equal to V2 is equal to we can feel V2 the combined capital. Ideal gas equation. Ideal gas equation. Then we that void that is 1 upon this is from the void. V is like proportional to this from our volume like proportional to the number that is our gas. Okay. And that V is like over and if that R will be kept once that V is like V is equal N and change it like V equals not the item is N is and R is gas one. This topic we have to do that is kinetic theory of gases. When gases what is we have to know five learn five I'm discussing about I'm telling that is principle as and and okay. This is easy to just make a just use a trick here. 0, 1, 2, 3. F, E, D, F. If it is X, but then D, E, then E, then F, then D. You can use other plus 1. Okay. But we have 1 byte 0 for the B, we have 2 byte we'll keep 0 plus 1 minus 2. For the D, we have 5 bytes. That is 0 plus 2 minus 1 minus 2. For the we have now byte 0 plus 2 plus 3 minus 2 minus 3. Okay. This have if the electron has got this, then it will be and if it will be and it will be minus. This is the way how you calculate. First, but I'm saying like scandium atomic number electron. Okay. Calculate. Also given that calculate will be 1 2 2 2 is 6 3 s 2 3 is 6 3d 1 configuration this configuration that scandium. Yeah, uh, 9 select. Okay, and 6 10 then 2 12 then 11 80 and then 90 on this format. Okay, you take this one 4s 4s 2 6 let me 4 in starting. This is the value of n in simple quantum numbers. N is equal to very easy. The value L is 0. So L value is again 0. And 1 is 0. L is 0. But if so this is 18th electron, 19th electron. Since the 19th electron is 21. So clockwise. So if the clockwise, then S equals plus plus. You find the number. And mark is very repetitive in the type of. Let this like 20 electron. Configuration 1, 2, 6, 3 is 2, 3p 6, and 4 is 2. Okay. So, just 8 electron. Where is electron? Yes, electron is 2p. Okay. 2p 6. This is the target. And whatever the value 2. For L, p will be as 1. So it will be 1. For 3 of it is 0 plus minus 1. So 6 will be the 1. So 2 to 4. Then this 6 select 7 select 18, 19 select 20 select. Oh, sorry. 2 to 4, 5, 6, 7, 8. Okay, I'm doing it again. Wait. So that there will be no confusion. 0 plus 1 minus 2. Okay. 4 are then 5th, 6th, 7th, 8th, 9th, and 10th. This is 8th electron. 8th electron is minus S. So it will be minus. So this is the quantum number. Yeah. So the important topic, topics I'm taking nowadays, like we have done the redox, all the important topics we have done. Only I'll take an competitive questions of this. chapters, whatever are there, I will try to complete. Okay, so just till then, just revise the question and we'll discuss in next class. Thank you.